The standard normal distribution. Z-values, or often called z-scores, represent the number of standard deviations that a given value is from the mean. This helps us to determine the position of any value within a given set. The z-value for a data value x is a set of normally distributed data given by the formula z is equal to x minus mu over sigma. So really what that's saying is we're going to take the value minus the mean divided by the standard deviation, and that's going to give us our z-score or our z-value. So in our first example, we want to find z if we are given this information, so we're just going to plug it into our formula. So we have that z is equal to x minus mu over theta. That gives us 18 minus 22 over theta. I didn't mean theta, sigma, over 3.1. All right, when I work that out, that's going to give us about negative 1.29. So what that means is our z-value or our z-score that corresponds to x is equal to 18 is going to be approximately negative 1.29. What that really means is that 18 is about 1.29 standard deviations away from the mean, or in this case, less because it's negative, less than the mean. Same kind of concept, we're just solving for a different part here. So we have that z is equal to x minus mu over sigma. That means 0.73 is equal to x, what we're trying to find, minus 39 over 8.2, and this is just an Algebra 1 type of problem. Multiply by 8.2 on both sides. So 0.73 times 8.2 is going to give us 5.986. And then we're going to add 39 to both sides. That's going to give us, 44.986. Okay. All right, so when we do that, the next thing that we want to do is to, whoops, didn't mean to flip that. We want to find the z-score. So the z-score, we actually know the z-score, right? We were told the z-score here. We found x. What we're trying to say is how far away that x is. So that's what we mean by indicate the position. So x, so 44 or almost 45.986 is 0.73 standard deviation, so less than a whole standard deviation, above, because it's positive, so that's to the right, of the mean. The standard normal distribution is going to allow us to assign actual areas to the intervals created by z-values. So here we see that different distributions can be compared once they're standardized using those z-values. Here we have the standard normal distribution, and this is a normal distribution, but the mean is 0. So what we're going to do is basically take whatever your data is, and your mean would be, well, it could be anything, and we're going to standardize it. We're going to basically put them all in the same scale, sitting in the same spot, and that way we can compare the data to each other. So standard normal is going to have 0 as your center, almost like a regular number line. The total area under the entire curve, just like we did with the regular normal distribution, was 100% or 1. Almost all of the area between -3 for z and +3 for z is going to be in there. Remember, every standard deviation we move out, we're more and more of our values in there. So 68% was one whole standard deviation away in both directions. 95%, 99.7%. And that's really what these are standing for. So -1 is one standard deviation to the left. +1 is one standard deviation to the right. The distribution is symmetric, and here the mean is 0. A standard deviation is 1 unit. So here we have the number of videos uploaded daily to a video sharing site. It's normally distributed with mu is 181,099 videos. The standard deviation is 35,644 videos, and we want to find each probability. All right, so we want the probability that our videos are going to be between 180,000 and 200,000. So what we want to find are the z-scores for each value. So for that 180,000, we need to find the z-score. So we have z is equal to x minus mu over sigma. Let's see, that's 180,000 minus mu, which was 181,099 over 35644. All right, and again, we'll just take a look at this in our calculator. We're going to get negative 0.03 for our z value. We're going to do the same thing for 200,000. So we'll use the same formula. 200,000 minus 181.99 over 35,644. And that's going to give us about 0.53. Okay, so what that's telling us is that the first number, that 180,000, is negative 0.03 standard deviations to the left. 200,000 is almost half of a standard deviation to the right. So what we can say is that our the range of z values is going to be between, so the range of z values, and often you're going to see these in other textbooks called z-scores. It really is interchangeable, is going to be between negative 0.03 and 0.53. All right. So from here, what we need to do is find the area under the curve. If we can find the area under the curve, and what I mean by that is, if this was normal and our middle is 0, we're going down negative 0.03 and up 0.53. I need to know the area from here to here. If I can figure out this area, that's going to be my probability. So I can use my calculator to do this for me. To find the probability, we're going to use a graphing calculator. The first thing I want to do is adjust my window just to make sure I can see everything. So because we are only really talking about going out at most really 3 standard deviations, we're going to go into our window and make our x negative 4 to 4. That way we have a little bit of wiggle room. Also, we don't need to go very high. So if we use our y min of 0 and our max of 0.5, that should be more than enough for us. So I'm going to leave there. And I'm going to hit second and then the vars button. It says distribution. That's really what it stands for above it. Okay. So once I've clicked that, I'm going to go over to draw and I'm going to choose the first option. I'm going to put my lower z-score in there. So that was negative 0.03. Then I'm going to hit enter. I'm going to put my higher one. So that was 0.53. I'm just going to hit enter a few times. All right, so there I have my shaded value. I see the area is 0.21 and change. And what that really means is that's the decimal form of the percentage. So that means that 21% of the time there will be between 180,000 and 200,000 videos uploaded on a given day. For x is greater than 250,000, we're going to do the same thing. We're going to find that z-score. And that is going to give us about 1.93. And then we're going to go ahead and do the same thing to find the percentage. For the next part, we want to find the probability where we're greater than 250,000. So we're going to do the same thing. We're going to hit second, and we're going to go to that vars button for distribution. We'll go over to draw. And we want to choose our lower as being 1.93. And we want all the values larger than this. So if we want all the values larger than this, we're going to say our upper is 4. Remember that if we were to go 3 to the left and 3 to the right, that would be 99.7%. So if we go 4, we're going to pretty much include everything to the right. We'll hit enter a bunch of times. It'll be pretty much the right answer there. And again, we're going to get our our area, and we will have our our value here. So we see that the probability ends up being 0.02677. If we round that, that's about 2.7%. What that means is that the probability that more than 250,000 videos will be uploaded is greater, or is about 27 or 2.7%.